Hey guys, this is 10-3. We're going to analyze functions graphically, and I'm going to go through and show you little cards of all the functions that we've learned this entire year, along with the equations that went with them. This is something that you'll have to know for Chapter 10 test and for the final too, so it'll be a good way to study. So try to guess as you go along. Hopefully some of them will look familiar, and then you can review the ones that you don't know. All right, first up. Yes, this is linear, has a positive slope. And for linear graphs, we learned several different formulas. The most common one is at the top, y equals mx plus b. Hopefully looks familiar. That's slope-intercept form. But we also did standard form and point slope form too. And then y equals x would be the most simple form of a linear equation. This graph is also linear. It is a straight line, just like the last one, but this one has a negative slope. So, and I actually graphed this one because you will need to know how to graph a line in y equals mx plus b form. So we can review that a little bit. The reason why this equation is y equals negative 2/3 plus 3 is because the slope is negative 2 over 3. The rise over the run, as I've shown with the dotted line there, it's in the negative direction, if you remember Mr. Slope guy from way back when. And the y-intercept, where it crosses the y-axis, is at positive 3. So same formulas as before. You can write those down, pause the video, take it in your notes. If you don't remember at least one, you'll only have to know one of these for your test. All right, next up. This is an absolute value graph. So remember, they have the V shape. This one actually has a negative a value, so it's pointing downward and has a maximum value at its vertex up here. And then I've also shown the axis of symmetry with the dotted line. For this graph, it's x equals 0, but remember that absolute value functions are symmetrical. And their formulas look like this. Could be as simple as y equals negative absolute value of x. I have that there because this one was pointing downward. So this does have a negative a value. And then the other formula. And if you'll notice all the way through this video, I have switched and used both y and f of x because they are interchangeable. Remember, f of x just means a function of x. So we are just telling you that this y equals equation is a function. Next. So, yep, this one is absolute value also. If you said that, good job. This one has a positive a value, so it's a regular upward V. So it has a minimum value for its vertex. Still has an axis of symmetry, though. It is symmetrical. And still has the same formulas. This time I didn't put the negative, so y equals absolute value of x, or f of x equals a times the absolute value of x minus h plus k. Next up. Hopefully the growth is a hint. This is an exponential function. So we learned lots of different formulas for exponential growth and decay and compound interest, simple interest. So here's a bunch of different ones. The important thing to remember here is for an exponential function, our variable x is always going to be in that exponent spot. Okay, so in all of these, as you can see that the x is always the exponent, or in the interest formulas, oh, and I got my finger over that. The interest formulas, it's t and n, but the variable is always going to be in that exponent spot for an exponential graph. And this one is representing growth. So pay attention to where that goes up and to the right. So this one is decay, still exponential, and it is going in the opposite direction. So it's showing exponential decay instead, unlike the other one. This one has same formulas. Remember with growth and decay, that's why I have this plus or minus. The one plus or minus are because the plus and minus determined whether or not it was growth or decay. And then I still had the compound interest. That's the interest formula, oops, on that corner. All right, hopefully we've done these a lot. Hopefully you know the name of this graph by the way it looks. This shape is called a parabola, and it is quadratic. So this one has a positive a value because it is going upward and has a minimum value at its vertex. I also highlighted the solutions. We've been solving quadratic equations, and remember that means that we're just finding what the x-intercepts are. When y is 0, what is the value of x? In this graph, it is 1 and -1. So I was showing that here. We did several formulas too for quadratics, standard form and vertex form. So, but also just the parent function, the most simple way to put it would just be the y equals ax squared. The important thing to remember about a quadratic is that it has a degree of 2. So we're looking for that squared term when we're talking about quadratic graphs. So quadratics can also be negative and have a negative a value and open up, the parabola can open up downward. So this one has a maximum value for its vertex. These also have an axis of symmetry. So parabolas, remember, are symmetrical, just like absolute value graphs. These solutions, I wrote them as coordinates this time. The solution is, one of them is at -1, 0, and then the other one is at 7, 0. And I have also shown the different, the vertex form, the parent function, but with showing that it was a negative a value, and then standard form of a quadratic. This graph is a square root function. Hopefully you guys are remembering these since we've done these recently. The x-intercept, remember that's where it is. Oh, and I put x. This should be y. Oh, yay. That's okay. You guys know that I make mistakes and correct myself all the time. The y-intercept, I'll just put x-intercept also for this graph was -1. So remember when we talk about intercepts, it's just where it crosses those axes. So I'll correct this one though. That's a y. Now y-intercept is at +1. The x-intercept is at -1. That -1, where that bottom of that graph is also a minimum value for these. This is also translated 1 unit left from the parent function. So remember, the square roots are the square root of x, or the square root of x minus h plus k. So hopefully you can remember that since those are more recent. Just showing you another, this is actually the parent function with a minimum value for square roots. So this one hasn't been translated at all, and still has those. I'll kind of hold that for a minute if you want to pause and take down those formulas. Remember, you only need to know one that makes sense for each type of graph. All right, that's what you have to put on your test. All right, and last but not least, what type of graph is this? Yes, if you said cube root, you're exactly right. Good job. You've been paying attention and doing your homework and watching videos at home instead of playing video games. This one I've shown, it's important to know that for cube roots, For these that have been only translated, this one's only been translated down 2 units. This one would have a domain and range of all real numbers. And one of the ways to represent that was negative infinity and positive infinity. So I've shown that here. This one, yeah, it moves down on the coordinate plane 2 units from the parent. And really similar to square root function, this cube root is just f of x equals a cube root of x, or the cube root of x minus h plus k. So I hope you have learned all these graphs and you are able to look at the graph and just be able to tell by the shape what type of function it is, and then a few things about that function that are important, like axis of symmetry or intercepts or maximum minimum values. So that is how you analyze functions graphically.